A member of the original Macintosh developer team, Scott Canaster is the author of How to Write Macintosh Software and Macintosh Programming Secrets.
Creating great Macintosh software isn't hard, and it doesn't mean that you have to throw out everything that you've already learned. It just means that you have to think about things in a different way. The fundamental change is something that we call object-oriented programming. Now, when we say those words to developers, we get lots of questions, like, first of all, what is it?
Object-oriented programming really has the unique attribute that it very closely models the way that people think and people solve problems. And once you kind of see past all the semantics of it, you suddenly realize that, hey, you know, if I had really been thinking clearly about this, this is the way I would have done it.
A big difference between object-oriented programming and procedural programming is in how they handle control. When you have a procedural program, the control resides in one big control structure, which knows how to dispatch to different parts of the program and knows how to deal with all the different kinds of data that the program has to handle. But in an object-oriented program, there is no big central control structure. Instead, you send messages to objects. The objects know how to respond and deal with these messages in the appropriate way. So, in an object-oriented program, the control is decentralized and it resides with the objects themselves.
Initially, I had a little trouble with flow control within a program. In object-oriented programming, you sort of have to give up being in control. You just know that your methods are going to get called and that your objects are going to take care of themselves, but you're not sure who's going to call you and when.
Object programming and Mac App let you think about programs in a more natural way that lets you go directly from the way things work in the real world to the way they're going to work in the computer when you're done. This also helps you create code that's reusable in different applications and programs that are more easily maintained as the years go by. Now I'd like to take some of your questions.
If you're already familiar with Pascal or C programming, what type of learning curve is there to start programming in an object-oriented language?
I started out with no object programming experience, and within a couple of weeks I was able to modify object programs to do things different from what I started with, and within a month we had a prototype working.
It was scary for a while because we were, I don't know if we were the first people using Mac App commercially, but we were pretty darn close. My previous experience had absolutely no object-oriented programming, but the beauty of object-oriented programming, I think, is that it so closely models the way that people think and the way that people try to solve problems that you don't need to have experience with it to understand what it's trying to do.
Catherine and Evan started from scratch, and both were able to learn object programming and Mac App well enough that in 6 months they had completed their applications. So it's not like going to the moon or something. And most programmers who learn object programming really see and appreciate the benefits that they get from it.
Over the life of a product is really what you have to look at, is how much time is spent maintaining it and so on and so forth. And that is definitely reduced with Mac App. It allows people to come in on other people's projects and know exactly where to look for things because the code is all written the same way. It writes a major part of the user interface for you already, so you don't have to go in and redo that.
I had to take over 3 other people's code. Now that is a fairly substantial task, and we hadn't completed the project, so I had about a month until the software went live. And I was able to use all of the code that the other people had written because I knew what methods the code was going to be in. I knew the structure of the code because I knew the structure of the objects. And when you have 4 people working together and they're all working on the same types of objects, you automatically know where things are going to be. So it makes for very maintainable code.
Is it possible to convert existing programs to object-oriented? And if so, how easy is it?
About 3 years ago, I was embarking on a new program, and I had gotten a few months into it, gotten quite a bit of it done, and was just starting to have a lot of problems because it was getting to be very big and hard to handle. And I made a really big decision and decided to try it. And for me, what that meant was taking the application that I was writing and start entirely from scratch, which is essentially what I had to do, and rewrite it with Mac App. And I'll tell you that that starting from scratch and rewriting it, it took me about half the time to get it back to where it was using Mac App, and not really because I had already written it, but just because the organizational aspects of Mac App made it that way.
Users demand that Macintosh programs have the look and feel that they're used to with all the other programs they've used. The best way to get consistent, compatible Macintosh applications is by using Mac app and object programming. I think the benefits really show up when you start running the business based on the application that you've written, because programmers will come and go, but you'll need to keep that application up to date. Now, maintaining an application isn't like maintaining a car, where all you have to do is return it to the way it was originally. Maintaining an application means adding things to it as you have new users and new things that you want to do. Object programming and Mac app are the best way that we know to let you handle that kind of maintenance.
We've heard a lot of nice things about object-oriented programming as far as development goes. What about performance?
Our application is a real-time quote display system. That means that we have to be fast. We cannot afford to not keep up with the other data vendors. We used Mac app and Object Pascal to do the user interface, and we've had no trouble with speed. We beat the leading data vendor by 2 to 3 seconds in quote display.
Most of the times in a program where it needs to be fast is very locatable. You can find the spots that need to be very fast, and you can make them fast. But by that point, you're at the leaf of the tree of programming. You know, you're off somewhere that Mac app has nothing to do with.
Okay, who's next?
I have to justify a lot of things to my boss, and they want to know specifically, is this just a fad? Is this something that's going to pass in several years, or is this really the way of the future?
It's not a fad because it's not just kind of an exceptional way to do something. It's just exactly the other side of the coin. And it just so happens that that side of the coin has the distinct advantage that it really models the way people do think and work.
I don't think it's a fad with me. It's a cleaner way of thinking when you want to build things.
Things are getting more and more complicated. And as they get more complicated, you need tools to handle that. And I'd hate to have to venture out with my old Fortran compiler and try to do the types of things we're doing today. You could do it, but you'd probably die trying.
Programming may not be a matter of life and death, but you want the programs that you write to have a long and healthy life and to be easily maintained, to have code that's reusable, and you want the people that follow you to be able to maintain your programs as well. And we found that object programming and Mac app are the best, fastest, and most powerful tools that we know of to make all that happen. Today we're going to talk about building a monster, which is a really good metaphor for computer programming. Monsters are big, they're scary, and you never know what they're going to do next, which reminds me of every program I've ever worked on. But also remember, monsters are usually the product of someone's active imagination. They're not as scary once you get to know them real well, and the good guys usually get them in the end. In this video, we're going to see two expert Macintosh programmers, Neil Goldstein and Andy Shebanow, as they go through the initial design process of a monster building program for kids. We'll watch them as they work through the 6 stages that make up the object-oriented design process. Stage 1, defining the tasks of a program. 2, selecting the real-world objects as models. 3, defining the behavior of objects. 4, refining the definitions. 5, defining the class hierarchies. And 6, writing and testing the code. What we did with Neil and Andy was to give them a task. We asked them, how would you design a program that lets very young kids build monsters by clicking on the screen? And then we step back, we turn on the cameras, and we watch them work. Now my job is to help you figure out exactly what they're doing by explaining the stages that they go through and also introducing what we call the 3 tenets of object-oriented design. We'll start with stage 1, where Neil and Andy define the tasks of the program. And just remember, in object-oriented design, the good guys always win.
Okay, so monster construction. Monster construct. Well, since this is a a children's drawing program, there's a lot of user interface involved. Maybe we should start with some idea of how it would look on the screen or what the user interface would look like.
Okay. I mean, it seems to me like we need to have some sort of, window palette thing like Mac Paint, where basically, you have the window which shows the kid the monster, and something, and sort of over here we could have like a toolkit or I mean a palette. I don't know if palette's the right thing, but a toolkit which sort of had body parts in it. So, arms and torsos and heads and that sort of thing.
One of the things you could also do is we could have this palette with some tools that we'll want to use to manipulate this object. We'll want to move it and drag it and make it shorter. Have the top part, for example, a bunch of tools like a little hand tool. Looks like a nice hand. And maybe we could do something like a sort of a tow truck so that they could move the thing around on the screen.
We've seen Neil and Andy working on stage 1, which is called Defining the Tasks. They've created a rough working sketch of how their program will operate. We saw them identify a palette of tools like in Mac Paint, and they talked about icons like hand icon or tow truck to move things around on the screen. Now let's watch as they continue to work through stage 1 and refine the user interface.
Well, let's go back to the user interface, because maybe that, as we talk about the user interface, that might affect the basic engine we want behind here. One of the problems being, of course, it's not completely defined yet, so as we're defining it as we design it, and we're designing it as we define it.
Right.
I think it's important that we really separate the monster out from the user interface, although some people would say that the user interface is the monster. We'll definitely need something like a tool palette, and some idea of a class of tools to do various things to these monsters, and then we'll need some kind of other palette which will have body parts.
Scrapbook thing.
Or scrap, right, okay, well, this was our scrapbook.
Here Neil and Andy are moving into stage 2, which is the selection of the real-world objects that they'll use to model their design. Now you might wonder, what's the difference between selecting the objects in stage 1 versus in stage 2? Well, in stage 1, Neil and Andy picked the objects from the user's point of view. For example, they talked about the palette that the kids will use to click on to build their monsters. In stage 2, they want to look at things from the programmer's point of view. Let's watch.
We probably need some kind of menu, almost, or some kind of palette for the scrapbook for what kind of thing will be in the scrapbook, so you can switch back and forth. So you might have arms, legs, heads, which are composed, and then if you switch on heads, you may have a different one with head parts.
Right.
And whatever, and all the other things that we'll need. And then based on what you click here, then you have a selection here, and then if you're in the right tool over here, which is a drawing tool, for example, you can select this, and then
right.
It's also kind of fun is if you select this, it pops up on the screen automatically for you.
So you don't want to drag it off or anything?
No, you don't have to drag it. For little kids, that works better. But what you can also do is you can add an option so that it starts to bounce around the screen very slowly. And you have the cursor turn into a little net. And what happens is you have to grab the part and drag it over to where you want it to be on the body.
So what are Neil and Andy doing here? Are they creating a monster, or are they trying to see how monsters are created? This would be a good time to introduce the 3 tenets of object-oriented design. Tenet number 1 says that object-oriented design is a creative process. I think that's pretty obvious already, especially with these guys. And that leads you to the second tenet, which says that object-oriented design is based on constant adjustment and refinement. As we watch, we'll see Neil and Andy constantly refining the design, even when they're almost done with it. That leads to the third tenet, which says that multiple stages are often working at the same time. Object-oriented design lets people solve problems in the way they naturally think about them. That is, jumping around from one idea to another or one stage of the process to another. You don't always have to follow things in a linear fashion as set down by the 6 stages. So if you look at an object-oriented design, you won't always find that people followed the 6 stages in order, but you will almost always find that the 6 stages were followed at some time. As our third tenet predicts, we'll continue to see Neil and Andy working on stage 1, which is defining the tasks of the program, at the same time as they're working on stage 2, which is selecting the real-world objects.
Let's start with the basic engine first of the body parts.
Right. I mean, basically, I mean, it seems like, all right, we start at the top. We've got the sort of the body, and the body knows that, okay, you have to have some legs, and okay, maybe you have to have some arms. So, you know, legs, and arms.
So
and we could set it up so there could be many arms because monsters.
Okay, so but we'll have definite subcategories. The body will have a number of composite objects that it knows about. Can you have a body without arms? Can you allow that?
Sure.
Okay, we have to, well, I think the only limit we have to have is what there can be there as opposed to what has to be there.
Right.
They don't have to have anything.
Well, I think, yeah, I mean, we may want them to have some kind of locomotion ability.
Okay.
You know, maybe we should take this abstract element, maybe have a blob, and the way it moves is by rolling,
Okay.
you know.
Yeah,
so,
I like that.
So maybe rather than calling them legs, you could have
Locomotion.
locomotion or something like
I'd like
that.
to have a head be able to bounce its way across the screen. I think that would be fun.
The objects that they designed earlier in the process are now being refined as they look at them more carefully. For example, here you saw them changing the idea of legs into movers to give them more flexibility in the design. You'll notice also that they're starting to think about the actual behavior of the objects, which leads us to stage 3. Defining the behavior of objects.
So this gets us back to the tool discussion, okay?
Yes.
Which is that, okay, they know how to draw themselves, they know how to animate themselves.
Right.
Okay, so, you know, what's the argument? I mean, why would a tool know how to drag a part around?
No, it wouldn't know how to drag a part around as much as it is know the right messages just to send to the part to tell it to do something. So if we have a part just draw itself to a particular frame, then we've solved a lot of issues, I think, about resizing and a number of other things.
Right.
And it turns out, I think, we'll also solve the problem of being able to add on to it.
In stage 4, which is refining definitions, they start to make their objects smaller. They also work to encapsulate the objects and to simplify the communications between objects. This makes programs more understandable and so more maintainable.
I think eventually we're probably going to want to take the head and actually have the heads be editable, so you could like have like a wolf head with the mouth of a gorilla on it.
Oh, absolutely. I think the head, we need to go through do the same thing, and that is divide the heads into its appropriate parts, like noses, eyes, ears, and mouths.
How's that going to filter back over here? How are they going to edit the parts of a head?
Well, when we hit a head, instead of having a bunch of heads up here, we'll have just a bunch of parts. Or in fact, what you can do is you can have it at 2 levels. You can have a bunch of pre-constructed heads, which are constructed already from the parts which we already had, and then, or they can just look at the parts themselves.
Okay.
So the monster is really the coordinating collection of all those parts.
Right, and that's the thing which is going to do all of the funny stuff once it's built, and sort of is also the thing that has the rules that, hey, you know, in order to have a complete monster, you have to have at least this much.
In their continuing process of refinement and problem solving, Andy and Neil have now started to move towards stage 5, which is defining the class hierarchies. To help identify class hierarchies, you can try the is-a or has-a test. For example, a leg is a body part. That suggests a hierarchy. On the other hand, a head has a nose, has a mouth. That suggests ownership and not a hierarchy. Now let's continue with Neil and Andy as they attempt to work out the relationship between parts.
Let's do the parts first.
Okay.
You know, one of the things we can do, we talked about the kinds of things. So obviously we're going to need to have sort of a generic part, which I guess is our first.
Right, which is a part class, right?
Okay, and parts know how to, let's see, they know how to animate and make sound. And they know how, I guess they know how to draw themselves sort of statically.
Let's jump ahead and see how they work out the details of how each part communicates with each other part.
Is the relationship between the parts themselves, or will they act independently of each other? Does a part have to know about any other parts?
That's an interesting question. For instance, yeah, I mean, if you're moving a mouth around, if a mouth opens, should that affect the nose?
Perhaps.
Yeah.
Do you want to open a mouth larger than the nose is?
Yeah.
At the beginning of this last scene, Andy and Neil touched lightly on the possibility of polymorphism. That's when you have an entire class of objects that can share some properties. A head, a torso, an arm, or a leg is a body part. These parts have passed the is-a test, and so they become part of their list of generic parts, which make the part class. They've organized it into a category so that the user can send one message, let's say animate or make sound, and all the parts in this class will then perform their own appropriate action. This allows them to use polymorphism in making the program more maintainable and more expandable. Now, let's watch as they work on the communication between objects, keeping in mind that object-oriented design is a constant process of revision and refinement, so don't be surprised if you go off in a direction that leads nowhere.
If a leg is going to move, you don't want to, it shouldn't have to ask the head if it's okay for the leg to move.
Well, think about what triggers it. The leg wants to move, right?
Right.
So the leg probably needs to ask the torso if it can move in a particular way, as opposed to the torso knowing about the leg that's attached. Although the torso might have to know what kind of leg it is. Torso have to know what kind of leg it is? No, that's the leg's business.
Right, that's the leg's
business. Okay, the leg knows what it can do,
right,
and then it decides it wants to do something and asks the torso, can I do this within your constraints as well?
Yeah, the more we talk about this, the more it sounds to me like maybe the connection stuff should, in fact, be inside of the part.
That was another example of how all the design stages tend to blend together. Now, in this next scene, we'll watch Neil and Andy as they begin to test the program by running a scenario that checks to see how the program will perform when various things happen.
You have to come up with something else, another behavior, which is, you know, when an object does something, when it moves, it sort of tells or asks, you know, is this okay? And it sort of asks everybody on its list.
Right.
Can I do this? All right, I like that better.
There's a relationship from part to part, which we've defined here, but there's some also relationship between all of the parts. And I don't know how far we want to institute those kind of limitations, because certainly in the monster you would say, well, you can only have one head, maybe. Although that's not a legitimate restriction.
Right.
But there may be some kinds of restrictions that we want to have. So
Certainly
the monster is going to sort of be the overall, it's not quite systems model, but just sort of the overall integrator of these. So we need a world manager.
Right. Well, yeah.
No, it's sort of like, it's almost like a god figure, right, that manipulates or keeps track of where everything is.
Yeah.
Really like a director.
Okay, fine.
Okay.
I'm sold. Call it a director.
Okay, I'm a director. Let's say I want you to walk across the screen as a monster. So what do? I don't think we have that connection. Well, that goes back to the idea of the script. Say I don't want you to just draw yourself because the views become invalidated. I want you to move across the screen.
Right.
So I send a message to the monster to animate itself with animation 1.
I think essentially there's two separate steps. I think that the director has okay, this director has a list of things to do. Okay, and at its level, things are very high level, like, okay, move to here and then eat this city.
So we're going to have a discrete level of actions, right?
Right.
At some level of complexity. We're not quite sure yet. And there'll be and each one of these monsters will be able to do a particular action. So it's really sort of some kind of intelligent
all of these things,
animate
all these actually animate and speak, all these guys in a sense go away. And really it's just like do action.
Right. Okay. Yeah, that's good.
Okay. And the same thing essentially in this case too. You don't have, we sort of get rid of this, and we do action here. So this guy here
that's great.
is at a smaller level, and we sort of can feed it through, so that when this guy gets to do action, he's going to say, okay, I want to move 3 steps, and so he knows to tell the leg, okay, move forward this far, and then some period of time later, he's going to tell it more, give it more information.
In the previous scene, we saw that many parts of the design were still unfinished, but Neil and Andy were able to resolve them and fill in the holes by working through with scenarios. For example, they discovered that they needed a director object and different levels of action, and so they added that to the design. Now let's watch as they're ready to present the design in a more refined state.
Okay, so I think that's pretty good. Sort of gone through it.
Okay, so I have a director with a bunch of higher level scripts or actions. So it knows about a series of actions that a monster can take, sends a message to the monster to do the action. The monster in here interprets the action somehow, which is in our little box here called an object, and it sends messages to each one of the parts to do their particular action as part of that overall action. So good, we've discovered animation.
Yes.
Now let's go back and look at the final tune-up as they head toward the coding stage. And you'll see that even though they're far along in the design process, they're still changing things and still refining. Here they're going to look at another scenario, this time from the user's point of view.
So pretend you're a kid.
Where are we with it? So I'm a kid,
Right.
you know, Evan, and we start out with an empty slate. Let's just erase your beautiful little head there.
Oh.
Okay, so we start out with the empty slate. The kid also has palettes in there. He goes over and selects a body first. He puts the body up, and the body comes up here. You get connections that show up, and then these various places. Now,
You know, maybe you want to also allow them to move the connections if they want in more
right,
advanced
and that's
mode.
the other thing is that, you know, maybe what if you want to have a four-arm monster?
Right.
How would they add more connections on there? That's an interesting question. So maybe one of the tools that's on here is sort of a connection editor.
Yeah.
Okay, going back to the scenario. So we have these things up there. They can go through. They can edit the connections. Then they go over here. They select a leg. They can drag the leg up. In this case, the leg has a foot, so it only has one connection on it. At that point, the leg is there and sort of shimmering. And
I like the shimmer.
yeah, very important. And they can then select it and drag it. I mean, it's already selected, but they can then drag it over onto this guy here. And once they do that, then this guy would highlight and this guy would highlight. So that one works. What other operations thing? They're going to do the same thing with heads and so on and so
Right.
forth. All that works very straightforwardly. The next thing would be they're going to want to be able to test, presumably, to test this thing out. So presumably they'd have some button on here, which is an animation tool or something. Don't ask me what that symbol means, but
It means vague.
yeah. So they click on that tool, and at that point, all the connections go away, all of the highlights and editing things and so on and so forth go away. And then maybe, without having a script in the director or anything, we just like basically tell the monster
You know,
just do action, sort of the default, sort of do your default action. And then that guy will in turn ask every part simultaneously to do an action, just to do its thing. Yeah. Okay. So that works for me. What else should we check out? Is there something we're missing?
Well, as we're talking about this, one of the things that strikes me is you want to be able to expand the scrapbook of monster parts. You know, one of the problems that kids have with kids' programs, and I've been watching this with my daughter Sarah, is she gets really bored if it doesn't change over time. She wants to be able to add new things to it and make new features. So if we could take the scrapbook and just open it up and say you can add any kind of picked item to it as a picture, and maybe have some kind of editor now that you can add more kinds of body parts to it.
Okay. You could have that if those parts don't animate.
Right.
Right.
Or even you could say it's this particular kind of, I want to add a new kind of leg.
We could have like another body part type, which was like picked leg.
Yeah.
Right. Or that kind of thing. We could even do multiple inheritance and just have a picked part and then have the leg.
Oh, let's
part.
do that.
So once they're comfortable with the basic design, Neil and Andy are ready to move on into stage 6, which is writing and testing the code. Once more, Neil and Andy demonstrate that object-oriented design is a fluid and creative process right up to the end.
For me, it's not always a requirement that the design be completely finished
Sure.
before I start, but I'd like to at least keep some of the things I want to do in the future in mind, so I'd at least design that in there. I don't have to have it all cast in concrete. As you know, it's going to change over time anyway.
Okay. Sounds good.
That'd be fun.
So we're done?
Yeah, so I think we should code it.
Stage 6 is covered in detail in the other modules and labs in this course. We've tried to give you a feel for the basic tenets and stages of object-oriented design. Thank you, and remember that in object-oriented design, the good guys always win.